Hello guys, welcome back to my YouTube channel. I am Yashwant. I am back with a new topic called counters. Let us discuss about this topic. Counter is a register which is capable of counting the number of clock pulses arrived at its clock input. Counter represents the number of clock pulses arrived. On arrival of each clock pulse, the counter is incremented by 1. In case of down counter, it is decreased by 1. Initially, the counter can be positive as triggered or negative as triggered. N-bit binary counter has n number of flip-flops and it has 2 to the power of n distinct states. The maximum count that the binary counter can count is 2 to the power of n minus 1, that is 2 to the 2 to the power 2 minus 1 is 3, 11 in binary. After reaching the maximum count, the counter resets to 0 an hour of next pulse. Here is a truth table of counters. Counters has clock initially, clock counter output, state number and decimal counter output. Initially it will be 1 0 1 2 3. Here counter output has QB and QA where 00 01 10 11 00, and here the decimal counter outputs 0 1 2 3 0. The types of counters. Counters has two types: asynchronous counter and synchronous counter. Asynchronous ripple counter. Asynchronous ripple counter is also known as ripple counter. In next slide, we will see the 2-bit asynchronous counter in which we have used T type of flip-flop. Rather than T flip-flop, we can use JK flip-flops by setting the both inputs to 1 permanently. The external clock passed to the clock input of the first flip-flop, that is F flip-flop A, and its output, that is passed to the clock input of the next flip-flop, that is F flip-flop B. Here it is shown in block diagram where logic 1 is connected to TA and TB, where QA, the output of flip-flop A, is connected to the clock of flip-flop B, and QB is output. For JK, higher state is connected to input of JK, and Q, the output, is connected to the clock of next flip-flop, and higher state is connected as it is for JK, and the output from Q flip-flop AQ is Q0. Here is the timing diagram for asynchronous counter. Operations of asynchronous counter. When both the flip-flops are in reset condition, when the first negative clock edge passes, when the second negative clock edge is applied, when the third negative clock is applied, when the fourth negative clock is applied. Asynchronous counter. In asynchronous counter, the present counter's output passes to the input of the next counter, so the counters are connected like a chain. The drawback of this system is that it creates the counting delay, and the progression delay also occurs during the counting stage. The synchronous counter is designed to remove this drawback. In synchronous counter, the same clock pulse is passed to the counter input of all the flip-flops. The clock signal produced by all the flip-flops are the same as each other. Below is the diagram of a 2-bit synchronous counter in which the input of the first flip-flop, that is flip-flop A, are set to 1, so the flip-flop will be working as a total flip-flop. The output of the flip-flop is passed to both the inputs of the flip-flops. Here is a diagram. The explanation is in past slide. Here is how timing diagram flows. Operations of a synchronous counter. when both flippers are in reset condition, when the first negative clock edge is passed, when second negative edge clock is passed, when third negative edge is passed, when fourth negative edge is passed. Thank you for watching my video.